What is up, everybody? Welcome to the Ham Radio Crash Course. Welcome to Saturday. Special interview this weekend, talking about remote ham radio with my friend George, KJ6VU, from the Ham Radio Workbench. Maybe you've heard of him. I bet you have. Anyway, enjoy the memes, and we'll get started real soon. How's it going, everybody? This is Josh, KJ6VU. Thanks for coming on out. So, special interview. So, we were going to do something fun with Ham Radio Deluxe, but I have that scheduled for next weekend, so make sure you come out for that as well. But we've got a great opportunity because George reached out to me after seeing some of the things I'm doing with my Flex Radio. I haven't gotten totally to the point of the fully remote station like we're going to talk about, so I hope everybody follows along. Of course, the Flex Radio is remote ready, of course, but there are some interesting things you can do in addition to that if you want access to everything in your shack, and I think George is going to help explain this a little bit better. So let's bring him on and say a big hello. How you doing, George?
Hey, Josh, I'm doing great. How are you?
I'm well. So I saw you on Mike's stream, and then you sent me an email saying, hey, this might be right up your alley. And I think it might be. It might be exactly right up my alley. So maybe give everybody kind of a roundabout idea of what we're going to be talking about. And I will add my personal spot of like I'm at and I need help with, and I think we might be talking the same game.
Yeah, sure. So the reason that I pinged you is that I was talking to Mike on Ham Radio Tube about a new product that I'm coming out with called a station controller. And so for a little bit of background, so most people know me because of Pactenna. So I make portable HF antennas for field operating, but also I've been making repeater control systems for about 19 or 20 years now. And so I've done a lot of control systems.
Had no idea. Had no idea.
Well, it's a niche of a niche. So, unless you're in that space, like who would know, right? Mm-hmm. So I've been interested in remote station operation for a long time, and I've been wanting to make a control system to go around my shack. And I started building some bits and pieces a couple of years ago, and that's kind of accelerated into a brand new product line that I'm coming out with this year. And when I saw your videos about getting your Flex Radio and wanting to do remote control stuff, I thought, well, if you're interested in that sort of thing, you might be interested in the kind of work that I'm doing to enable you to control and monitor the stuff that sits around the radio. So we can go into, well, what does the radio do versus everything else? So that's why I pinged you.
Yeah, that's actually a really good way of explaining this. I was thinking to myself, how do I explain to everybody what sure, the radio's remoted, but then there's everything else, right? And so, well, maybe you just tell us what are the things. So people go buy a Flex, or they go buy an ICOM and they have an SDR control application, right, that they can use with their phone, or any number of remote control capable radios out there. They go out and buy it, and they're like, okay, I got my radio connected to power, got Ethernet, got an antenna, and then they go away, and then what happens?
Yeah, exactly. So what about all the other stuff? So the problem that is solved out of the box by companies, like you said, like Flex Radio, Elecraft, ICOM to some extent, and more, I think everybody's going to go this way, is to make the remote control of the radio features easy to do. So change the frequency, change the mode, press to talk, all that. The other thing that's a solved problem for these manufacturers is shuttling the audio back and forth, or the FT8 or whatever it is you're operating. So being able to get data in and out of the radio and control the radio, that's really the problem that the radio vendors themselves solve. Now, that's great because that's the most important thing to start with. But once you solve that problem, then you start to ask yourself, well, what about all the stuff that sits around the radio? So what could that be? So it depends on how you want to run your remote station, but it could be things like turning the power on and off. It could be switching between different antennas or different radios to one antenna, so coax switching. It could be monitoring the voltage on a battery system that's in your remote location. It could be checking the temperature of your power amplifier. So there could be a whole long list of things that you might want to control and monitor that are not the radio itself, but you want positive control on that stuff. And this problem is really an important one to think about for HF radio remote. But many of the same kind of requirements are there if you operate things like a repeater site.
Yeah.
So I've been building and running repeaters for decades. And I also always wanted a system that I could instrument the repeater system. So if something goes wrong, I want to know what failed before I go up to fix it. So being able to monitor and control the key sort of vital signs of your repeater is just as important as doing a remote station.
Yeah. So one of the big things for me is if you spend a decent chunk of money on a radio like a Flex or just one of the other radios you mentioned, and you're in Barbados sipping Mai Tais, and you key up, and then it doesn't unkey.
Right.
Now you're in a pretty scary situation because your only connection is to a radio that might be having a bad time with something. Right, you were doing FT8 a second ago, sipping on Mai Tais, but then now your radio is in some kind of a death spiral. You don't know what's happening.
Right.
It shows T transmitting, and you're like, oh geez, oh unkey, and it's not doing it. It's not you've lost control effectively. So you need at the very least, from my point of view, a failover. You need that big Frankenstein power, switch, blade switch that you can yank remotely to take power away from everything. So I think that's like the fundamental starting point. And then, not to mention rotors. A lot of us have beams, and how do you control all that stuff? So okay, I get it. There seems to be I'm finding, as I've talked to people in the remote amateur radio space, that there are a lot of options, and they all will do almost all of the job, but it's kind of spread out. You got to go buy this box from this company and this box from this company and all this other stuff. So how everything I'm saying just rambling, or is this kind of what you're putting under one tent?
No, you're spot on. So,
okay.
So to your point about the remote power control, that is sort of fundamental feature number one is you need positive control. In fact, even if you're running a repeater system, the FCC rules say you must have positive control of your transmitter. Yeah. You need a way to shut the thing off. Whether it's DTMF or a landline or a whatever, you need some way to get to it. So in the same way, we need to have positive control on our HF stations. So if something goes haywire, you need to be able to hit the big kill switch. So like you said, for 100%. Now you might also want to turn the power on and off, just because why leave the power on 24/7? You don't need to, so you might want to turn it off. If your remote site is battery operated, then power consumption is a big deal, and you might want to make sure stuff is all shut off except the bare essentials. So that's all kind of really a requirement. So now, in a way, I would say half of these problems are solved today, one way or another, like you were saying, Josh, from random consumer electronic gadgetry that you staple together and you build your own system. Hams are resourceful, right? They'll go find like an AC web switch and they'll install it. And now you point your web browser at that AC web power switch, and now you can turn it on and off. So in a way, problem solved. Where it becomes a bit more of a challenge is, number one, you may find there's 4, 5, 6, 7, 8, 9 things now in your remote station. Each one has its own website, and now you have to have 8 different web pages to go control all this stuff. And those things don't necessarily talk to each other very well also. So what I really wanted to do is to make more of an integrated system that is very modular and expandable, so that you can start small and you can build out from there, and will allow you to not only control generic stuff like turn the AC power on and off, but do more radio specific things like RF coaxial switching remotely. So
Yep.
let's say at a very bare minimum, even if you have one antenna, you'd like to be able to switch between your antenna and a dummy load, for example.
Absolutely.
A lot of us have a vertical and a wire or a beam or whatever, and you want to switch between 3 or 4 different antennas. So it'd be nice to do that remotely as well.
I Yeah, well, I mean, it's I want to be away from home because I'm a human being and I have to do things with the family. They keep telling me that, and I want to still do radio things. And
Hmm.
sometimes QRP is great, and doing POTA is great, but sometimes I want that big old station at home, or I want my nice, rotatable antenna that I can point in a certain direction, maybe chasing DX. And so I want all the things that I would normally touch if I was in the
Hmm.
shack at my remote control, right? So
Yes.
you've got a modular solution, which probably seems like the best solution. Is this hardware and software, or how are you bridging the gap there?
Yeah, it's the system is hardware and software. So I can show you in a moment here what it all looks like. But there's a set of hardware modules which provide different kinds of functionality, and then there's software to control it all. So the base architecture, kind of the out of the box version of using the system,
Hmm.
you would have one module that has a Raspberry Pi as your host PC, and it runs Node-RED, which is really the ideal control
Sure.
platform because there's literally thousands of hams out there that are already using Node-RED, and there's a lot of smart people who have built a lot of Node-RED infrastructure. Guys like Kyle AA0Z's done great videos on the
He's in the
subject.
chat.
Oh, is he really? Okay,
He's
hi
in the
Kyle.
chat.
Mike Walker, VA3MW's done tons of videos about specifically Flex and remoting stuff and using Node-RED. So I thought, well, obviously you want to base what you're doing on Node-RED, and you can run it on a PC or you can run it on a Raspberry Pi. I make a hardware module for a Raspberry Pi now that has a 12-volt power supply, high range of voltage input to just plug right into a ham station. So it's got the Raspberry Pi. Then there's a set of modules that do different things. There's a general purpose I/O module that's got voltmeters and small
Ooh.
signal relays and temperature sensors and stuff like that. There's a coaxial switch relay module that lets you switch between different antennas or radios. There's a RF wattmeter module that lets you measure the RF power. And the architecture is such
Okay.
that you can have one of these modules or all of them or 3 of each one. I mean, you can keep adding them because every module has an address and they all talk together on a network. Essentially a proprietary wired or wireless network. So one of
Yeah.
the cool things too about, we can get into this, is the
Hmm.
way the architecture is set up. You could even remote these modules. Like you could put an antenna switch module at your tower and switch antennas and talk to it either over a cable or over an RF data radio,
Ooh. Okay.
like a 900 megahertz radio, and it all seamlessly works together.
Oh, so you're talking if it's a great distance away, potentially, more
Yeah,
than
in
just
fact,
Ethernet or more than just
so,
Wi-Fi.
and this is
Yeah,
kind of,
I'm assuming you have a repeater example of this is where you're going
well,
because you said 900 megahertz. So okay, all right.
yeah. So 900 megahertz for data radios.
Hmm.
In fact, this is sort of jumping way ahead, but as long as we're talking about it, I even made a Meshtastic module because Meshtastic
Oh,
is such the thing. Um,
why not?
so
Why
so
not?
why not? So the way the architecture of the system works is the Raspberry Pi, like you press a button on the virtual control panel. The Raspberry Pi sends a command to the network. The network is either wired modules or it could be wired into this little RJ45 connector and go into a Heltec V3 LoRa module. It then transmits your control command over the LoRa radio
Hmm.
to a remote LoRa radio.
Okay.
It receives the message. The controller at that end executes the command and sends acknowledgement back to the Raspberry Pi to
Hmm.
the Node-RED dashboard and updates the dashboard. Now, a bunch of people are going to say, "Holy cow! Don't put data over the long, fast mesh." Of course, you'd come up with your own private channel.
Sure.
But my point is that you can literally have control points RF connected,
Hmm.
in the same room, across a room, a mile away. I mean, you could do all kinds of stuff because of
Mesh,
the modular architecture.
right, and Meshtastic, based off of LoRa, was literally designed for this kind of stuff because this is basically
Yeah,
sensors data in a lot of cases, or very subtle, easy commanding.
yeah,
Before you get
exactly.
into,
Yeah, go ahead.
I'll ask you a question. I don't want to forget this. So before we get into showing us, um, is there any failover that you have built in if the Raspberry Pi goes down? Because I'm like, who watches the Watchmen, right? Like, so
Yeah,
you got everything on a Raspberry Pi, which historically I don't have the largest amount of faith in a Raspberry Pi. So how are you dealing with that?
yeah, that's a very, very good question. That sounds like a question that comes from experience
A Raspberry Pi is failing,
somewhere.
yeah.
No, just in general. So
Yeah,
so
yeah.
let me talk about the architecture a little bit more
Hmm.
for a second. So the architecture, the most simple way to think about it is that you have devices and they all talk on a common interconnection. That interconnection could either be wired or wireless. And the wired interconnection between the modules uses RS-485, which has been used for 40 years in industrial automation. There's a bunch of reasons for RS-485, not least of which is it's what's called a multi-drop network. And what that means is that I can hang multiple devices physically on a twisted pair of wires. Okay,
Okay.
so what this means is that I can take one or more modules and I'll hook them up dropped off the same twisted pair.
Okay.
Now, at some point, you can have that twisted pair go into a module and come out as a data radio transmission to another module, then go back into a local wired network. So
Okay.
you can mix and match wireless and wired together, and everything's on a big party line. So to your point about how do you deal with failover, let's say I have my Raspberry Pi and it's working just great, but it poops out for some reason, it freezes up. If I had a second Raspberry Pi or a PC or whatever also sitting on the network, it can control the
Oh.
network as well. So there's no device that has to be the one and only master control point.
And
So
you
if I
and you
had,
have that in the architecture where something can fail over and
yeah,
take.
so
That's
if I
cool.
had two, so this is the Raspberry Pi
Hmm.
module.
Okay.
So on here is a RJ45 with that RS45 connection. If I
Okay.
had two of these boards, I could just hook them together, and they both have different IP addresses. And either one of those devices could either send commands to the network or receive commands from the network,
Does
and
that
they
mean
can
that your
operate in parallel.
user does that mean your user interface has to be smart enough to be able to switch the commands to the appropriate one? Or does it just
No,
go into like a FIFO
it's no, it
hopper
just
and
goes in
gets.
parallel. Think about it this way. Let's say you
Oh,
have
it's
two.
I get it. Yeah, it goes to that
It's
one
simpler
first.
than
It's
you
like a
think.
token ring. It's almost like a token ring. So
It's
it's going to hit that one first and then go to the next one and go to the next one. If it doesn't hit that one, it skips over to
no,
the
so
next.
it's not like a token ring.
Okay.
It's more like Ethernet. It's more of
Okay.
a multiple access medium where anybody can talk at the same at once. Obviously,
Okay.
there could be a collision, but there's so little traffic in this application that's not really a problem. Simply put, and this is really, by the way, a real corner case that we're talking about. But anyway,
Oh,
let,
okay.
let's
Okay.
let's say I wanted to be super redundant. I could have two Raspberry Pis or a Raspberry Pi and a Lenovo PC or
Hmm.
whatever.
One of those cube
Um,
PCs that it's all the rage these days.
yeah, absolutely.
Yeah.
A little, GMK Tech NUC for
Yeah.
$100 or
Yeah.
$200. Yeah,
Hmm.
it worked great. So what you do is you take a little dongle that plugs into the USB port on that device, and on the other end is the twisted pair, the RS-45. You
Okay.
just bust that together with the rest of them, and now I have two PCs wired in parallel on the control network. If either one of those PCs sends a command to the network, the receiving devices will accept the command. They're all addressed, so they'll
Hmm.
decode only their commands, execute the command, and then send back an update payload. And then both of their devices will receive the update, and they'll both update their web pages because they're both listening on the network.
Is it like a first come is the one that responds to the command? So if
Um,
I'm on the web and I go rotate my antenna to 90 degrees, the first device that grabs it is the one that
no,
processes it?
no, they're all addressed. So every device in the
Oh.
network has a unique address. So when you set the devices up, you say, okay, your device one, your device two,
Oh,
your
okay,
device
I got
three,
it.
your
Okay.
device four.
Yeah.
And so what happens is everybody's listening on the network at the same time. Everybody's grabbing the traffic that's coming across the network
Yeah.
and parsing the data. And if it
Hmm.
sees its address in the to field in
Got
the
it.
packet, it goes,
Hmm.
oh, that's for me. Takes the payload, drops it into its command processor, and goes, okay, is this a legit command that I can execute? And
Right.
if it is, then I'll execute it. And if not, I'll just ignore it.
So then you'd have a button on your custom website that would be Raspberry Pi commands and backup device commands. They'd be almost identical, but they'd be addressed to the appropriate
Yeah,
computing
you could
device.
you could do it that way. I mean, the way I would do it is I'd have two PCs on two IP addresses running the same exact flow. They
Mhm.
have the same exact functions. You could press a button on either one, and it would trigger the event to happen on the device.
Mm-hmm.
And when the device executes that command, it sends an update packet back onto the network that says, okay, sent master device, here's my latest status. And what would happen is that if you set up those two Raspberry Pis in this example as both being the master, they'll both receive that packet and they'll both update their web pages and they'll just look the same and they'll just be operating in parallel.
Interesting. Okay. Okay.
Now,
cool.
by the way, just to belabor this whole point, one more thing.
Yeah.
So one of the first things I did with this, the first thing I built was the coax relay board. And the reason is that in my shack, I have multiple radios and one antenna. Mm-hmm. And I wanted to be able to switch between the antennas or between the radios. So sure. I took a Stream Deck and I wrote a program so I could press a button on my Stream Deck. It launches my little utility program. It sends a serial command to my antenna switch, changes the switch position on the coax relay, and then so I just changed antennas by punching a button on the Stream Deck. The command that changes that sends the command from the Stream Deck, I could have a Raspberry Pi with a web page sending the same command. So I could even have my Stream Deck running in parallel with my Raspberry Pi running Node-RED, and they would both happily work together.
Ah, okay. All right. I'm liking it even more. Yeah, because that's always the scary thing is you got to have the redundant. You're adding the redundancy so that you don't have your devices fail, but then you got to have redundancy on the redundancy, if you will. But
yeah, and by the way, with Node-RED, you can do some really cool stuff. Redundancy aside, you can do some really cool things like there's people that have written Node-RED applications where they'll look like I think Kyle did this. Like look at the weather in your region, and if there's going to be lightning or whatever, then automatically send a command to disable, disconnect your radios from the antenna.
Yeah.
You don't even have to be there, and it just does that for you automatically. Now, that's not something that the Flow does that I ship out, but you could add that, so that's something you can do yourself.
I guess that's one of the fun things about Node-RED is it's approachable enough that almost anybody could do it if they were so inclined to do so.
It is approachable. It's not super trivial, but it's certainly doable. The best thing about it, like any other technical thing, there's a big community.
Yes.
And the big community is really the value, because either someone's already written a program to do the thing you want, like control the rotor, or you're trying to do something that's never been done before, and you could at least post the question to the 1,000 members of the
right.
And say, how do you do this? And like somebody's done it or something like it, and they can help you out. So that's been very positive.
Yeah, there's got to be a workflow for most things you could think of probably at this point, unless you really are getting off the trail. But okay, so
right.
I saw this on Mike's video. By the way, if you want to hear George talk about Pactena and all the stuff he's working on that, go check out Mike's video. I will drop it in the link, or I'll drop it in chat and add it to the links. But really good job there. But this is primarily focused on this remote radio stuff because I'm super into it. But yeah, so how do we do this? What do you want to show it? You want to
Yeah, why don't we just look at it to start? Yeah, let me show you what it looks like, and then we can kind of drill in if we want to in any of the details. But probably pictures worth 1,000 words. So
yes.
So let me switch my camera.
You can share, and I'll give you the full control.
All right, let's switch over here. Okay.
If you can embiggen that might be helpful. It looks like you're in portrait mode. You might need to go to landscape if you can.
Yeah, I'm in landscape on the camera, so I don't know why it looks that way. Let me see.
Let me see if I can do something.
I think it might be on your side.
I can't do anything other than just have you as a view. So
okay, let me try. Here, let's start with this. So this is.
Okay.
What I just was showing you is actually a whole system. So let's look at the individual modules. So we'll start with this one here. So this is the Raspberry Pi module. So a module is a printed circuit board, and you could mount the circuit board in a box, however you want to do it. There's a couple ways you might install a control system like this. You might want to install it horizontally, like in a 1U chassis box, because you want to put it in a rack and keep things really small, so you can certainly do that. You can also mount it vertically. Personally, I think mounting it vertically on like a telco wall, a piece of plywood is the way to go if you have the space for it, because there's always a bunch of wiring and rewiring that you're going to do over at least the first, probably 6 months until you get it, all the features that you can think of. All of the modules are a circuit board, and then there's also a optional base plate that fits all of the modules so that the backs of the circuit boards are not exposed to anything on the bottom. And you see there's a bunch of standoffs in the corners because there's going to be some optional top plates if you want to put them on. These base plates are designed to use DIN rail clips. So the way I like to do this is use a piece of DIN rail. DIN rail is commonly used in industrial control applications where you've got things like relays, for example, where you're going to mount that relay to the DIN rail. And so basically, you can put these plastic clips on the back of the board and they just snap on the DIN rail. So all of these modules could easily snap onto a DIN rail if you want to do it that way. So I tried to make it as flexible as possible so you can have different ways to deploy it. So this is the Raspberry Pi board. Now you could just take a Raspberry Pi and plug it in. You don't need to use my module. What the module does though, is it gives you a power pole and a barrel jack connector into a power supply, which could power the Raspberry Pi from basically any voltage you would encounter in the ham shack. So you can plug in, 13.8 volts in here, and the power supply would be a really good high current supply to handle whatever Pi you plug in. This board also has 3 RJ45s. These are not Ethernet. So the wired connection between the modules uses Cat5 cable. And the reason I went with this route is that I mimicked what you find in power over Ethernet. So 2 pins are for ground, 2 pins are for 12-volt power, and 2 pins are for data, and they're all bused together.
Oh,
so
wow.
that if I have let's say my second device, let's say like this is the GPIO module, I could take a piece of Cat5 cable and just plug it into the module here, plug it into the Raspberry Pi here, and I only need to supply power to one board. And
wow.
the Cat5 cable will supply power and data to any of the modules that are plugged in.
That's great.
While I was at it on the Raspberry Pi board, I had a little bit of extra space, so I thought, oh, that would be perfect for a Heltec V3 Meshtastic radio.
Yeah.
So if you want to, you can put a Meshtastic radio right on the Raspberry Pi host adapter. So this is pretty straightforward and basic. So that provides the Node-RED server. Again, if you don't want to use this board, you can take any PC or Raspberry Pi you've got, and you could plug in a USB dongle to get to the same electrical connections as you have here, and just use twisted pair to connect up to other modules. That would be fine. But I like having I need to build a complete solution. So a lot of people, some hams are like, okay, give me the pieces that I can't make, and then I'll cobble everything together.
Right.
And then there's, a lot of us are like, man, that sounds great, but I don't have the time to figure that out. Just give me all the stuff that I could snap together and it'll just work. So I had to really architect this thing so it's turnkey. So that's what we got here. So that's Raspberry Pi. The first example of a control module is this one here. This is the general purpose IO module. And it has a bunch of plug-in header, or not header, but a bunch of plug-in terminal blocks that you plug in, and there's little screw terminals on there to attach the wires. But it's nice because they unplug. So what's on every one of the modules is its own microcontroller, its own interface to that same RS-485 network interface, and a USB jack. The USB jack is used for local configuration if you want to customize its behavior. So on this board, what you've got is 4 DC voltmeter inputs. These are 16-bit analog to digital converter, so it's pretty high accuracy. And they read between 0 and 50 volts on each of the 4 ports.
That's
so you would use
on the board?
Well, that's
or
preset.
It'll take it.
It'll take it.
Okay.
So you don't have to do anything. You just plug in 0 to 50 volts, and you'll see that on the meter on the Node-RED dashboard.
Got it. Those are all the meter controls, or the meter receivers.
Yeah. So essentially what happens is, let's stop there and say, well, how does this really work? Let's say this was connected over to here, and this is running Node-RED. You can configure the Node-RED software to either only address the devices on command or to poll them periodically. The board is constantly reading all of the inputs. And so at the drop of a hat, the board is ready to send status back to the Node-RED dashboard. So if I set it up in automatic mode, the Node-RED program will poll each of the devices as frequently as you tell it to. So let's say every 20 seconds you say, tell me, give me the data, give me the data. Every time you press a button on the dashboard to command the board, it will respond with all of the values of all of the inputs to the board and give you a real-time update. So you've got 4 voltmeter inputs. Then there's open collector outputs. There's 4 open collector outputs that are designed to control 12-volt relays. So if you have a large 12-volt relay, then you could use this. You just have to connect it up to the coil of the relay, and you're good to go.
Oh, cool.
There's four small signal relays built in that gives you a dry contact, single pole, single throw switch closure. Then there's 4 digital inputs that are opto-isolated. So you can, let's say, put a switch closure on any of those 4 inputs to give you, let's say, like an alarm condition. You could put a magnetic door alarm on your building, and if the door is open, then one of these will fire. So you'll know that someone opened the door or whatever you want to do with it. Then up here we've got 2 digital temperature probes. These are DS 18B20s. They're very popular digital temperature probes, no calibration required. You just plug them in and they work. And there you go. It's got built-in power supply and the dip switches for configuring the address of the device. So that's probably the most generic and probably the first device most people will get. Now, if you want to, go ahead.
So you would need the Pi board though too, right? To start, and then you'd need the interface board.
You would need the Pi board. So the minimal configuration is this and this.
Okay.
Assuming you want the GPIO kind of I/O. Now, by the way, if I said, look, I just want to use my Stream Deck and punch a button and have it flip the relays, I could do that with a Stream Deck. But sure. I can't really do much with the voltage and other measurements coming back to the Stream Deck. It doesn't know how to deal with that. So then next module, this is the HF relay, coaxial relay module. So this guy has 1 common and then 4 other ports that you can switch between this one and the other 4. So you can use this as 1 radio to 4 antennas, or 1 antenna to 4 radios. Or you can have 2 of these and hook the commons together and do 4 antennas to 4 radios. You can do multiple units. Everything else on here is very similar to the GPIO module in terms of its general system features. The microcontroller, power supply, the wired interconnect bus is all here. USB for programming and configuring. So this is a very simple device. You press a button on the Node-RED dashboard. It says select port number 3. It disconnects whatever port it was on. It connects to port 3, and off you go.
Yeah, I noticed that there's a BNC. Do you have an option for SO239?
Not in this form factor. So the problem with SO239s and N connectors is that there's not a PC board mountable version of that connector. So to get something compact, BNCs are a good way to go. And I'll be supplying pre-assembled cables with BNC to PL259 as an option. So if you want, like we just shipped out a bunch of betas and I threw in some cables, so it'll go from BNCs to PL259s. Now you could do this in a chassis box, and you could have N connectors. Really for HF, you just use SO239s, but there's more to assemble when you do that, and you have to be able to mount those connectors to the chassis somehow. Now, there's another option, which is you can mount this in your own chassis box if you want to, and get it without the BNCs populated, and just run a bus wire to, let's say, a bulkhead where the SO239s are. So you just have a little piece of wire running to the board, which is the way most people would manufacture such a thing anyway. So you could do that if you want to.
There's a question in the chat. What is the power rating of the coaxial relays?
It's rated for 100 watts. The most I've tested on it is 100 watts. One of our beta testers has a Power Genius duplex amplifier. So we're gonna we're gonna find out
Ah,
how much it's gonna handle. The way it was designed, it should handle a couple hundred watts. It's not supposed to handle a kilowatt. So it'll easily handle 100 watts. And since
okay.
radios are either 100 watts or more, a lot more, I'm rating it for 100 watts at the moment.
Okay.
Now, by the way, it's also rated as an HF coaxial relay. I ran it on the tracking generator spectrum analyzer, and it's fine at HF. It's fine at 6 meters. It's actually usable at 2 meters. It's not bad at 2 meters. At UHF, it's not very good. So I would not use it for UHF, but it's not too bad at 2 meters. There's another design that I'm looking at doing that is for VHF, and instead of using inexpensive relays like these, which are fine at HF, the VHF version is going to have an impedance controlled relay. The
Hmm.
problem with that is that they're really expensive. Like if you just bought that relay raw from a supplier, that relay is like $50.
Oh, wow.
So that turns it turns these into much more expensive products. But
Right.
I may do that anyway, but that's kind of down the road. One other important thing about this is that these are latching relays.
Oh,
What
good.
that means is if you select, let's say, port number 3 and you pull the power, it's still hooked up to port number 3 without power.
Right.
And then when it boots up again, it'll know what the last state was and make sure it stays in the proper state. So even if you lose power, you're not going to lose connectivity between the relays.
That's what I mean.
Um,
Yeah. Good.
so that's probably the second most popular thing, I think. The third one, or really the fourth board, I don't have right in front of me. It's over on the little picture, is the RF monitor. So let me switch over there. I know that the picture is going to be tiny, but so here, what you see is all the stuff I just talked about, and then some. So on a piece of plywood, this is the Raspberry Pi module.
Hmm.
That's the GPIO module. This is the 4-port coax switch, and this is the RF power monitor. And I just have a prototype of that, so I don't have a bunch of them to show. And this uses a wave node directional coupler. And so we can use different directional couplers. So this is a 0 to 2000 watt HF coupler. There's a
Nice.
0 to 60 watt. There's a UHF, VHF one will support all of those. And they just plug in here, and you could plug in 2 watt meters into the controller. And again, you can have multiples of each one of these. So you might say, well, that's all great, but I need 3 watt meters. Well, you can get a second one of these boards. It has a different address, and then your Node-RED application can see 4 watt meters.
That one board can take in multiple watt meters?
Yeah, this can take 2 watt meters.
Oh, wow. Okay, cool.
So there's port 1 and port 2. Now, and what's cool about the watt meter, out of all of these, I probably spent more time working on the watt meter module because there's kind of more to do. So you have to come up with an algorithm to sample the RF power and give you a meaningful number. And there's a couple of modes here. Like one mode is every time you see the LED blink, it's actually sampling that port. So it's constantly reading what the sampler is reading. So you can set up thresholds like if you ever measure a reflected power more than so many watts, send me an alert.
Hmm.
You can activate this from the Node-RED dashboard where it goes through an entire test cycle, or you can press a button, and there some of the connections here you can wire up to mechanical buttons. So for example, if I press the activate button, what will happen is it will cause this line to key up. So put the transmitter and push to talk. It'll sample the wattage several times. It will calculate an average and then report back what the wattage is. So right now I've got this thing hooked up to a FT991. And so and it's set for like 40 watts. So when I hit the activate button, it starts the test, runs a dozen samples, and then comes back and says 41.08 volts or watts.
Oh, wow.
Plus, obviously, it goes to the dashboard. So this is what the Node-RED dashboard looks like. Sorry, it's kind of wonky on the camera.
Yeah, can you, what are you on a phone? Is that a phone?
No, it's an Osmo. Um, let me see if I
It's an
can do it.
Osmo.
Yeah, it's the
Oh,
DJI.
yeah. The is it the Osmo Pocket 3?
Yeah.
Yeah, you it it doesn't like going into landscape mode. That is definitely the Osmo doing that. I have
Oh,
to I have to drag the video out to make it full size.
okay, we're gonna do this the handheld way, so
Yeah, there you
sorry
go.
about that.
No, you're good. And so this is wired up. This is wired up and running to a radio right now in your shack, right?
Yeah. See, you can see it over there. That there's a FT991. That's that dark box over here.
Mm-hmm.
It's hooked up to that. So let me see if I can get closer. Okay, here's the watt meter. So let me show you how to trigger it from over here. So here's the Node-RED dashboard. Left-hand side, this is the GPIO module. There's 8 relays on there. You can go relay on, relay off, and there's a little LED that shows you the state. This is the antenna switch. Which of the 4 antennas do you want to select? And the LED tells you which one's active.
Mm-hmm.
4 digital inputs on the GPIO board, 4 voltmeters on the GPIO board, 2 temperature sensors on the GPIO board, and then on the RF watt meter, forward and reflected port 1, forward and reflected port 2. And you can see the last time we sampled the wattage, it says 41.08 watts there on the little meter. So, so what I'm going to do here is I'm going to come down. You can barely see the little cursor there on the first green bar.
I see it. Yeah.
Here. Okay, I'm going to click that. Click. Now it's running the test on the watt meter. And then it will come back and update over here. Now it's going to be the same wattage as it was before, but
sure.
And let's say if you want to flip a relay, so go to the upper left-hand corner, relay 1, the top left one there, I'll click it. And then you can see it change state, or click it again, and it'll turn off. Now you'll see when I click it, there's about a second or 2 delay from the time that I click it to the time that it registers the click.
Mm-hmm.
And the reason for that is that when you press the button, like press the relay on button, it sends the command from the Raspberry Pi to the GPIO module. It actuates the relay. Then the module sends an update command back to the Node-RED dashboard to tell it to change the LED. So it's a positive control loop, if you will.
That's good. Yeah.
And then the last thing down here, the antenna selection, like let's pick the Yagi. You can hear, maybe you can hear a click because those relays are kind of big. So it's selecting the different antennas. And then on the coax relay module, you can see here if I select different antennas, there's port
cool.
1.
Yeah.
Port 1, port 2, port 3. And you'll hear 2 clicks because one click is that relay disconnecting, the old one. Then you have a delay, and then the new relay clicks in.
What's your
so you don't have to switch.
Yeah, sorry for interrupting you there. What's your little you've got like a cat Ethernet cable hub in the middle. Is that also part of the setup?
This guy here?
Yeah.
Yeah, so again, it's not Ethernet. It's my own network, what I call the device control network.
Gotcha.
So it's the RS-485 and power. So let's say you had this station controller with 3 modules and the Raspberry Pi. There's 3 connectors already on here, so you wouldn't need this. You could just run one Cat5 cable to each of these 3 modules from here, and you're done. But if you want to expand it, let's say I want a 4th or 5th module, then you could get the hub. And the hub not only provides power and data between the modules, it's also a power injector. So you can put your 12 volts in here, or here, or here, or actually on any of these modules. In fact, in this example, the power is coming into the GPIO module, and all the power is distributed to all the boards from there.
Yes. So Kevin in the chat, yes, these are all PoE. They're all PoE, and you can pretty much power them anywhere.
It's like PoE, but it's not E.
Oh, right. There's not E. Sure.
Yeah. And also it's 12 volts, not 48 volts.
It's power over George. Your special.
Yeah, that's right.
System you've designed.
The other thing that's kind of cool is if you do go with the DIN rail approach to mounting this stuff, there's tons of aftermarket stuff you can buy. Like you can get these super skinny little relays with LEDs. I hooked up to the open collector outputs of the GPIO module. You can get like this aftermarket voltmeter to just monitor the voltage of the bus. There's tons of things you can get to add on if you go with that form factor. Again, if you don't want to mount it to like a plywood thing like this, you could just mount all these circuit boards to the inside of a 1U chassis box.
Yeah, that was a question that came up earlier from Jody. They were asking, is there some kind of an enclosure option? Do you have something that you're looking at, or are you thinking that the implementer is going to be the one that's going to do kind of what they want to do?
Yeah, it's a really good question. I think what I'll probably end up doing is having a 1U chassis version of the enclosure for this. But surprisingly, that's not cheap. Like a metal box, a bespoke metal box with the holes where you want them, could be as much as one of these modules to manufacture. So,
Sure. Yeah.
so I really have to figure out exactly what the right form factor is and the hole positions and all that, and make enough of them for it to make financial sense. So the answer is probably yes, but not in the next, say, 6 months.
It's kind of also, I mean, you're talking about a situation where a lot of hams are just going to have this in their shack, right? So you may not need a lot of enclosure type stuff. I could be wrong.
Yeah, I think the place where the 1U version of an enclosure makes sense is like if you're putting this in a repeater site to
Sure.
monitor, all that stuff, then that's probably makes a lot of sense. Most shacks don't have network racks, although the nicer ones, kind of do. And you can put this stuff anywhere. It doesn't have to be like right at the operating position. It can go anywhere. In my shack, I have a desk with the radios on it. And then on the side, the legs that hold the desk up, I have a plastic utility box, if you will. It's
Hmm.
about 15 by 20 and about 6 inches deep. It's a plastic box. I screwed it to the side of the desk, and that's where I put my antenna relay. So I, you know,
Oh.
and quite frankly, that was the most convenient thing because if you put it in a conventional box, one of the challenges with this kind of a thing is there's a lot of wiring. And if
Hmm.
you have a box with a bazillion wires going into it, like it's very inconvenient, especially
Yeah.
if you want to change things.
Although I like what you've done in kind of reducing the amount of wires, or at least keeping them to where they're just kind of interconnecting to each other to some degree. I appreciate that. But yeah, we got
Yeah.
enough wires going on in most of our shacks to it's enough. So I do appreciate that, and I like your power solution as well. So then I guess so if I already have, so I know you have the RF switch that you made, but I already have one of those Ethernet type RF switches, right? So
Hmm.
how does that work? Because I need to get it into your kind of network, if you will.
Yeah. So that's a good question. There's different kinds of things you might want to integrate.
Hmm.
Some things will be have nothing whatsoever to do with my stuff, and some things could leverage my stuff. Okay. So let's take, for example, you've got a Ethernet enabled RF power switch or power monitor or whatever.
Hmm.
If there's a Node-RED flow to read that thing, then you just incorporate that into your
Oh,
Node-RED control panel.
because
And
it's on the
and
network, and so is your Raspberry Pi. So
right.
okay, yeah, sure, got
So
it.
so remember, like the Node-RED thing, what I'm going to provide as part of the product is a Node-RED flow that you just saw here that has all the buttons and gauges to control and monitor one set of my hardware. And some people will just look at this and go, okay, no, that's it. That's
Hmm.
all I need. And they'll just use it and they're done. And there's other people that'll be like, I want to take your stuff and this other thing and some other thing, and I have some other ideas, and I'm going to integrate it all together into my own Node-RED program. But rather than have them figure out my stuff from scratch, I'm just going to give them a flow, and they could just cut and paste my stuff into their program and
Right.
hook up, the rest of the stuff however they like.
Okay, I like it. I like it. I see where you're going.
So part of
Mhm.
this is to make it. It's not really an open source project, but all of the control protocol for the network control is published. It'll be all in the documentation. So if you want to write your own program, whether it's Node-RED or Python or whatever, you can write your own software, and I'll give you the commands. And if you send this command to my board, it will send you this in response. And here's how it all works. And that's all published. So one of the reasons to do that is not only because some people like to, tinker, but you might want to design your own gadget someday. And it'd be nice if your gadget was compatible with my gadget.
Mhm.
And so if you can kind of follow my, the way I did it, then that would kind of make it easier for you.
Sure.
Um,
Now, going back to, I guess it was the GPIO board.
mhm.
You have the temperature probes that you can add to it, or the readers there. The meter side of it, though.
Mhm.
So, what type of meters would you be using in this case? I know it's pretty much a standard. You can up to 70 watts. You said 70 volts. Sorry, that
Oh
they
yeah.
get.
So temperature or well, so let's pick one of them. Temperature or volts. What would you like as an
Well,
example?
so the temperature ones, I think I understand because you would just use a standard temperature probe for that and wire it up to the connector that's already there.
Correct.
But then
Right.
for your meters that you'd potentially connecting
Hmm.
to it, which type of meters are you getting that do that, and
So
what are you?
So when you do this in Node-RED, somebody has built a library
Mhm,
already that has some kind of meter, and it could be like a half circle meter with a pointer, which is what I
mhm.
used, or it could be a horizontal bar with some kind of marker, or it could just be a big number. So
Right.
you pick whichever library of display elements you want to use. So in the case of the flow that I made, it uses probably the most common one, which is this half circle arc that
Yeah.
also puts the number in the middle of the circle. So when you configure that object in Node-RED, you can give it some parameters. So you can say, for example, okay, when you get a value, map that value to somewhere on this 180-degree arc with the lowest number is X and the highest number is Y.
Okay.
So for example, if I think, well, it's a 50 volt, my hardware will measure up to 50 volts DC. I'm never going to see more than 18 or 20 volts in the shack, I hope.
Hmm.
So I'm gonna change the parameters in that particular thing in my Node-RED program to say I want to go from 0 to 20 volts. I don't care
Hmm.
about 20 to 50. So I just
Right.
change a number in that as an attribute in that thing, and you're done. And
So
so now the meter will show 0 to 20 volts. It'll take my data, and anything in that range will be shown on that meter the way it's supposed to.
I get that side of it, the display
Hmm.
side of it, but the physical port, what are you plugging into
Oh,
that?
oh. So there's a terminal block, one of these things,
Yes. Yeah, but
and
what's on
and
the other
so
end of that? Like, what device are you monitoring on that? That's the
well, whatever
because
you
it
want.
sounded
So
like you had
so
everything included. So that's what I was like.
yeah,
What would you be plugging into that? That's what
good.
I didn't
Oh,
get.
okay, good question. So
Oh, a
so being a
battery, I
generic,
guess. You could do a battery, right?
yeah. So
Okay.
so what
Yeah.
I
Okay.
do, so what I so here's what I do in
Okay.
my shack is I want to measure the voltage coming out of the power supply
Got it.
that's
Okay.
running the HF radio. Okay,
Uh.
because why? Because let's say since it's a remote station, Murphy's law, something's not going to work, and one day it's going to be like, well, the radio's not on. Well, okay. So the first thing I want to do is I want to see, is there AC power in the shack?
Sure.
So I want to be able to check for AC power. And by the way, there's a cheap and dirty, not UL required way to do that. Take a wall wart, plug it into your AC outlet, and then take that 5 or 12 volts or whatever it is, and put it into one of the opto isolated digital inputs.
Right.
If there's any voltage
If
on
there's
that
anything there, it's
wall wart,
binary. You either
you've
have
got
it or you
AC
don't.
power.
Yeah.
So I mean that's like the quick and
Got
dirty
it.
way without
Yeah.
buying an expensive AC power meter. Okay, so that's one. So now I know, do I have AC on or not? Okay,
Hmm.
the next thing I'm going to do is take the DC voltmeter and I'm going to put it on the terminals of my power supply.
Got it.
If I see 13.8 volts, the power supply looks pretty good.
Right.
So if I see 10 volts, then I think there's something wrong with the power supply, or 0 volts, right? So that would be useful. If I have a remote station where I have a power supply and a battery and maybe solar panels. Now, there may be multiple places where I want to measure under different
Sure.
conditions. So
Yeah.
now, for example, I may want to have my AC power supply delivering uh, power and my hooked up to the battery and hooked up to the load, and I want to be able to, let's say, measure the voltage with the power supply on. Then I want to turn the power supply off and see what the battery voltage is.
Right.
Let's say you're
Yeah. Yeah.
using
Yeah.
some old SLA battery and it looks great when the power supply is on, but you turn off the power supply and the voltage is at 10 volts. I think you got a bad battery.
Uh,
Um,
yeah, there's all. Well, I mean, I see it now. Of course, now I get it completely, right? Because you are not there. You always have to. The thing that I'm like is I'm new at all this stuff with the remoting. I just have to tell myself, Josh, just pretend you're not there, and something goes wrong. What would you do first, second, third? And
exactly.
those are the things you'd want to have connected, so that you didn't have to exactly.
Right.
Got it. Yeah. Yeah.
So we're actually getting into like the vital signs, the health of the system. So the theory there is that you monitor all the critical vital signs. So do I have AC power or not? Do I have DC? What's the DC voltage? If the radio is turned on and I key down, how much RF power do I have coming out of the radio?
Got it.
So you're kind of debugging the system. Now, by the way, oh look, I've got key down 100 watts coming out of the transmitter. How much reflected power do I have? If I have 100 watts going out and I've got 30 watts coming back, I got a big problem.
Right.
If I've got 100 watts going out and I've got 0.05 watts coming back, it's okay. So, this gives you a way to monitor those critical signs. And by the way, these issues are exactly the same issues you have at a repeater site. I get up in the morning and I push the pickle on my radio and there's no repeater. What happened? Did the power crap out? Did my power supply fuse blow? Did my transmitter PA burn up? Is there the antenna fall off the tower? I mean, which so you want to probe all those points in the system and go like, what the heck is going on? And then you want to have some positive control. That's the other half of it. You want to be able to say, turn the amplifier on or off, switch the antenna, put it on the dummy load, inhibit the transmitter. So there's a whole nother. You mentioned, well, I want to go on vacation and take my remote my radio.
Yeah.
But there's a huge growing interest in clubs putting up remote stations. Now, one of my clubs that I belong to, a great club here, is the Portland Amateur Radio Club, and Park just put up a remote station, which happens to be a flex. Not didn't have to be, but it happened to be a flex.
Right.
And we're putting in one of my station controllers there to do all the stuff we're talking about. And the reason that the club put up the remote station is it's a big club with a lot of members. And, a lot of people live in an apartment and they don't really have access to an HF station that's very good. Or, they're old folks in, a place where they can't put up an antenna in an HOA or whatever. And so you want to maximize the monitoring and control of a station that's being shared. So here's this trivial example. Let's say you deploy the system, and one of the system administrators realized, oh man, we've got a problem with our antenna. The SWR is kind of high in the antenna. We better shut this thing off so people don't transmit until we fix the antenna.
Right.
Well, rather than just like powering everything off, you could leave it all on, but put an inhibit in the transmit line.
Oh, sure.
So
because they can still receive, or force them to only use antenna B, right, and just leave antenna A alone, because that's its own
exactly
problem going on.
Exactly.
One of the clubs I'm in, they have a lot of young engineers that can't afford a house in California, so they can't even set up a station. So they have a remote shack as well, and they're doing the exact same thing, but they're going the more disjointed 1,000 websites and a PDF file that's a mile long to manage all of it. And this is a way more nuanced approach. So I'm going to send this to the leaders of the club and be like, hey, check out George's stuff, because I think this is exactly what you guys need.
There's another dimension of that too, by the way, and that's reproducibility. So like, we've all been in a ham club where there was a project, and Bob, who's a genius, figured it out, right? So he built a system, and it uses often repeats and repeaters. Like, man, it's all singing, all dancing. It's great. One day, Bob's gone, and everybody else shows up, and it's like, how does any of this work? I have no idea. So that's kind of one other reason why off-the-shelf products, bespoke products for stuff like this is useful, but you have a big community like in Node Redland, and so it's easy to kind of start to learn and even start it from scratch if you had to, and yet you're not like starting from total zero.
So a couple of questions, and guys in the chat, go ahead and drop your questions now if you have them. Jody asks, George, does your digital I/O board support monitoring dry contacts or strictly opto-isolated, externally powered inputs?
The digital input it goes into an opto isolator.
Yeah.
And the high side of an opto isolator basically has a LED on 2 pins, and it's got a transistor on the other 2 pins. And when the LED is turned on, then it enables it, like pulls down the pin on the other thing.
Yeah.
On the other side. So essentially what you need to do is apply some voltage across the LED that's inside that opto isolator. And so I bring out both of the pins of the LED. So you can hook it up however you want. The most common way to do it is to put like a pull-up voltage on the high side of the LED and just ground, so the active signal to indicate activity is to pull it to ground. That's the most common.
Okay. I don't know if that answers your question, Jody, but he may have ideas. Jody may reach out to you.
Cool. Yeah. By all means, bring it on.
So I want to make sure we get the people information here. So I have the link in the video description, so go check it out. But it is at Sierra Radio Systems.
Yeah.
What was the?
So the company is Sierra Radio
Systems.
Systems, but the website is sierraradio.net.
SierraRadio.net, and I think I have you. Oh, that's the wrong one. There you are, right there. So, SierraRadio.net is how you find it, and the link is in the video description. And you've already sent out betas of these units, right? So you got a test group that's gonna give you feedback and all that fun stuff. And these are people who are, I'm assuming, already somewhat remote savvy, so you're gonna get some good info back.
Yeah, I would. So we got 10 betas. 6 of them shipped out this week. We have 4 to go. I would say probably 3/4 of them are very experienced remote station people, and then the rest are not. You know, it's like their first rodeo. So it's kind of a mishmash of experience. I mainly wanted experienced users because I want, I want the hard, like, why did you do this? I want the challenging question, but I also wanted some kind of new users as well. So there's going to be a bit of both.
Mm-hmm. Yeah, for everybody watching, I got a number of people in the chat who are like, "Wow, this is way over my head." So maybe answer that question, George. How would you approach somebody with this? It's like into HF. Maybe they're just a in front of radio single sideband person, and they haven't really thought about remoting their radio. Maybe they don't even know this exists, George.
Yeah.
How would you tell those people about what this does and what it is?
Yeah, that's a great question. The problem is when you're an engineer, you kind of
I know we're both like
you groove on like all the minutia. I think the trick there is once I get past the engineering phase, which is like you come up with a concept, you build a prototype, it doesn't work, you make some changes and you refine it until you get to the point where it's like, hey, this is pretty good. And you send those out as beta sites thinking like, okay, I think it's done, but I'm sure somebody's going to find an issue. So that's where it's at right now. So hopefully there won't be any big issues, maybe a few tweaks, a few enhancements. So then it goes into production. So by the time it goes into production, then the documentation has to be there. And what I learned selling products in the ham radio market over the last 20 years is that most hams aren't like me. So I have to anticipate a broader audience than myself.
Yeah. So
and mainly what.
No, sorry. Do you want to finish that thought, and then I'll interject for a second?
I was just going to say, like, there's kind of a spectrum of people that, one of the spectrum, it's like, I can probably design and build a thing like that, maybe. And then there's all the way to people who are like, I could care less, and I don't know how, and I don't want to know how. I just want a thing, and believe me, no value judgment, because there's a lot of things in my life that, like, I'm that guy too. It's just this one happens to be the thing I like to get into.
Mm-hmm. So yeah.
So I have to anticipate that.
Yeah. I've noticed from a ton of your kits that these are all things that are problems you're solving for yourself, and you're like, hey, maybe there's somebody else that might like this. Buy it if you want to, but otherwise, I did it for me anyway, so who cares?
100%.
Yeah. That's. I know that's you, like, in a nutshell.
And the pitfall of that is if you go, well, it was perfectly obvious to me that this complicated thing would work this way. Why are you so stupid? And the fact of the matter is that's a failure right there. I mean, you're going to crash and burn if you think that way. Mm-hmm. So I learned the hard way that what you really need to do is try to anticipate the case where someone is like, look, I have no time for this. I need to take it out of a box, snap, plug it in the wall, and have it work. And if it doesn't work, then I'm sending this thing back. So I have to shoot for that. And so a lot of the design of the thing was really geared around that. So what has to come next, to your earlier question, is I have to create the proper kind of documentation for anybody to just take it out of the box and use it. And by the way, by documentation, I will write something down, but I don't expect anybody's ever going to read it. So I think documentation is going to be like, watch this YouTube channel and watch this video, and in 5 minutes, snap, plug it in, and this is how it works, is going to be the documentation.
Yeah, it's really interesting. I've been reading some manuals recently, and I'm at the point now where we collectively, we're at the point now where once upon a time, we tell people, go adjust this knob. It says this thing on it. But now you've got software that doesn't have a knob necessarily, or it's a menu buried under a top drop-down thing, blah, blah, blah. And a lot of these manuals just say, go adjust this value. They don't tell you how to do it. Oh, my audio just freaked out. Oh, hold on one second. I got a puppy audio thing. But hold on one second.
Yeah, I understood what you said, but yeah, you just got garbled. So yeah, that's really important. I mean, like when I got my Flex radio, I never read the manual. It's like if I can't figure it out by twiddling knobs and pressing buttons, then I think there's something wrong with this design. So, I'm sort of in that same boat. So I need to make it as kind of simple as possible. By the way, at the same time, there's people who want to extend the functionality of a thing. And I appreciate that. And I want people to be able to do that. So I want to make it easy for people to take this as a base and then innovate on top of it and come up with your own customizations around it. So I think that would be great. It's better. It's not garbled. No audio.
There we go. Should be back. Back?
Yes.
Okay.
Yeah. Now you're good.
I don't know what this gremlin is. I had an audio interface fail on me. Focusrite Scarlett. I've been using it for years. Failed on me, so I bought the new one. And now you could live stream for like almost an hour or sometimes like 3 or 4 hours and not have it, but then all of a sudden it just starts going staticky. I went around and checked all the connections and I don't know what the deal is, but I got to go. No, I did it, Ted. I did the whole thing. I've done all the gremlin checks. I've got to apparently do it all over again, but yeah. So George, this is super cool. Obviously, again, for some of you watching, right? Some of you watching, I saw the comments, not fully understanding what's happening. But trust me when I say there is a growing population of amateurs that are interested in this remote capability. And it's not even, and we say remote, and I think that's even becoming a loaded term to a degree. I think people are using that as some kind of a tech, like, oh, that's the techno nerd geek thing, we're not really interested in. No, not really. So the dashboard that you saw George show, that's giving you the health and wellness of your entire shack and multiple points of checking without having to start tearing up things underneath the desk and go into racks and shelves and all that stuff to go do these point checks on all these things. He's created testing points and different meters displaying what the issues are before you even need to go do anything, right? I think that's one of the biggest parts about it is it's this whole metered approach. When you're just sitting in front of your radio, you could still utilize this for a ton of value, a ton of all kinds of important information.
I think you hit on a super important point, and that is that when you start talking about something like this, you need to be able to explain it in a sentence, which is like almost impossible, especially for an engine nerd. So I tend to talk about this as a remote station thing. The genesis of this was actually not even remote. It was just operating, like you were just describing. It's operating stuff in my shack. I want to sit at my desk. I want to press a button on my Stream Deck and switch antennas. I want to press a button and turn the power supply on. I don't want to flip 3 power supplies. I want to press one button and have all that turn on. So this is totally a shack automation thing as well, both real-time control and monitoring or automated where you set things up on schedulers and stuff like that to do as you like. So yeah.
Yeah, there's a ton of really good automation that comes with Node-RED and all the other stuff that doesn't even involve remoting, hypothetically. The remoting is just the gravy that you get after you kind of get through some of the initial process of this. And it sounds like, at least from what I'm seeing, that your product is designed to help make that a little bit easier and I guess also unify it a little bit under one common architecture instead of it being a hodgepodge, kind of as you were talking about in the beginning.
And give you the luxury of being able to extend it yourself if you want to. So, a lot of times you buy a product and it's like a closed garden and it does what it does and you have no way to get in or out of it.
Right.
And it's a fixed thing. And for a lot of us, that's fine. But there's times when you go, man, it would be really cool if I had a way to get in and like change something or integrate this thing with some other thing. And so this is going to be for those people who want to do that, like super convenient.
Well, thank you, Interstellar Sandman, for the super chat. $1.99 for my new audio fund. Man, that audio interface isn't cheap either. It's a couple $100 to do this. So I don't know what's going on. I'm gonna go deoxit all the things, I guess, out. the live stream. George, anything else you got to mention before we wrap things up? George is going to join us on the after chat. I guess I should mention that too. Everybody watching, join us on the after chat. I'm going to make a new live stream, and it's a fun little roundtable discussion on Discord. The link is in the video description, so you can join us. We answer whatever amateur radio questions you got pretty much, but George is going to join us, and so we'll try and keep things focused to the fun things he's working on. George, anything you want to mention? Any hot Pactena inventory drops you're about to make that people need to know about?
Yeah, so I'm constantly chided because I'm out of stock like seemingly all the time. But I've been trying to fix that, and so there's a whole bunch of Pactenas in stock, and I got a ton of parts for another batch. So our goal is to eventually get to the point where we're never out of stock. So Pactena stuff right now is I'd say reasonably well in stock, and hopefully will stay that way. The station controller, like I said, is going into beta right now. I want to run the beta for a couple of months before I make any large volumes in case there's any last minute tweaks to the hardware. So that means we'll probably have production units in March. Okay. And start selling them then. The goal was always to take it to Hamvention. So yes. So I definitely plan on being at Hamvention and being able to show it off there. But hopefully have them ready prior to that. And you can follow along if you listen to Ham Radio Workbench podcast,
which you should.
Everyone should talk about this very briefly on each. Thank you. On each episode in the Workbench thing, I've been talking about it a fair bit there. In fact, I got an episode coming up in a couple of weeks where we're going to take a deep dive technically. So if anybody wants to nerd out with me on going deeper and exactly how this thing works, then check that show out in a few weeks.
Excellent. Yeah, Ham Radio Workbench is always on my list to listen to, so you guys go check them out. It's a fantastic podcast. Thanks to Jason Lockwood, and Jody for the super chats rounding things out. Well, George, I'm going to wrap things up with you here, so if you want to hang on and I'll talk Discord with you, or I think you already know how to hop into our Discord. If you want to just jump over there, you can and start talking to the folks. But either way,
Thank you, Josh.
It's been incredibly I'm very excited. It sounds like something that's going to only kind of grow or maybe get more Oh, you know what? In fact, somebody mentioned that earlier. Do you have planned for other modules in the future?
Yes.
You just okay.
Yes.
So maybe there's a roadmap that you're building?
Yeah, just the things that are in my mind that I'd like to do next. I'd like to do the VHF or VHF UHF coax relay module, which ain't going to be cheap, but that's
right.
for sure one.
But that's valuable too for the repeater stuff you do as well, probably.
Yes.
To some degree, yeah.
Well, actually, there's people that want to be able to drop their power amplifier of the repeater out of the circuit. So you want to be able to switch, a 2-pole double throw around the amplifier to take it out of the circuit. So absolutely, there's use for that. So VHF, UHF, coax relay. I will look into the chassis boxes, both 1U boxes and maybe like a desktop box, but I'm not sure how that's going to pan out. The data radio module stuff, Meshtastic. I'm looking at doing a voice command module.
We didn't even talk about the Meshtastic. I mean, you mentioned it, but
we talked about it briefly.
Yeah, very briefly. So we'll have to have you back when you got it going.
So I got one little example to mention before we run. So I did an experiment. I used my iPhone on Meshtastic, and I just used text to speech, and I said, turn relay 1 on. And of course, the Meshtastic radio sends it over to the controller, and I prototype some code that just takes natural English words, parses it, and then it goes, turn relay 1 on. Okay, click. So you can actually do it really easily. I could do a voice to command interface.
You know what the next is then, right? Is you gotta connect it to Siri and to Amazon Echo and to all the other things, right? So that you have Alexa, make 20 FT8 contacts for me on 20 meters. Right, and you just set it off. There's the future,
Alexa,
guys.
Finish DXCC for me.
Finish DXCC. Wrap that up. Jeez, what's taking so long? George, thank you so much. As always, whenever I have you on, it's like that, and the hour's over, and we already got started late, but we still blew over time. So thank you for hanging
Josh.
around with me, and appreciate you having you on.
Anytime. I appreciate it. Take care.
All right. Thanks so much. Oh, man, I'm telling you, Ham Radio Workbench is a lot of fun. Very much more on the technical side of things than my podcast that I do with my wife, that's for sure. So if you're interested in that, you should really go have a listen. One of my favorite parts about the Ham Radio Workbench is they talk about what's on their bench, right? Their bench of stuff they're working on. And this is where you get the little inklings of information of what's fun that they're going to be doing. So appreciate George coming out and reaching out to me and telling me about his cool thing. A lot of people don't do that, and I love when people are willing to say, hey, I got something kind of fun you might be interested in. I very much was. So thanks again to George. Appreciate it. Everybody, come and join us on the after chat. We're going to wrap things up over here. The link is in the video description. We take your ham radio questions. That's our goal. George is going to join us for a little while, though, so we're going to ask him questions inevitably about Pactena and other fun things he's working on. So if you'd like to ask George a question, you didn't get your question answered, join us over there, and the link is in the video description. Very simple. Or just wait for my next live stream, and you can still type your questions out there. That'll work just fine. Huge shout out to all my patrons. Appreciate the support you guys give. It really, truly does allow me to do the fun things that I'm able to do to put into video to help bring more people into the hobby and educate where I can in the specific way that I can. Not probably going to be making a lot of systems like George does. He has a technical skill set that I certainly don't have, but man, I do have a lot of fun with doing all of this, and I appreciate all of the support. Because of this interview, we will be doing our Patron Picks episode next weekend. It's normally the first weekend of the month, so appreciate you bearing with me on that one. And we are drawing closer to the end of the year. Man, it's been a wild, wild year, but we got a couple of really fun we got a fun episode for Ham Nation in 2 weeks, and then we're going to have Ward Silver on real soon, as well as doing our Christmas light antenna video. I'm going to probably reuse an old design. We got really good success as far as performance off of a very specific design of antenna for Christmas lights. I'm going to reuse that, but I'm going to be using my new amplifier. So that's... My wife is standing next to me. I said the thing I shouldn't have said out loud, but yes, we're going to be using a new amplifier for these Christmas lights, so get ready for that. It's going to be a lot of fun. Shout out to the Coffee Club members. If you'd like to check out hamtactical.coffee or hamtactical.com for our merch, but hamtactical.coffee for a Coffee of the Month club, check that out. Appreciate you guys. All right, I'm headed out of here. My wife is waiting to talk to me, so 73, enjoy the memes. Oh, and I'll see you on the after chat, so don't go too far. The kids are bullying me.